Welcome to Web Handling. My name is Dave Roysum. What better place to begin our Material Matters mini-series than with basis weight? It is the most common of the web quality tests. However, common does not mean commonly understood. There are several concerns that can arise with this simple measure, as we will see in the next few minutes. I know your time is precious, so let's get started. So, why should we weigh the web that we are making or buying? The reasons are many. First, it is the most common quality measure in commerce. Weight is simultaneously an important attribute, machine setting, and test measurement. It is also extremely important factor in economics. Approximately half of the cost to produce a web is in raw materials. So losing tight control of weight may mean losing control of profit, even if you are in spec. Finally, it is a necessary alternative to measuring thickness, which is ill-defined for many soft and fuzzy materials, such as foam, nonwovens, textiles, and tissue. We will cover the measures and issues with thickness in the next clip. So, what exactly is weight? It is the mass or weight per unit area of a web. Both the mass and the area units must be specified because there are many options for both. For example, GSM or grams per square meter is the most common in the metric system. Oddly, the nonwovens and textile mills in the U.S. sometimes use OZY, or ounces per square yard. Paper is even odder yet, especially in the U.S. They use weight in pounds, and the area as a ream size, which may be 3,000 square feet for paper, 1,000 square feet for paper board, but there are others. Aside from carefully and explicitly defining the units, we must also define the test standard. The most common is to weigh 1 or 10 die-cut samples on a very sensitive scale. Online scanners, which can cost millions of dollars, infer weight indirectly as the absorption of nuclear particles from a nuclear source. The scanner is calibrated against the gold standard of weight measurement, which is still the old-fashioned weighing of samples. Here is a list of some of the most common basis weight test methods and standards. A much more complete discussion is found in Appendix T of the must-have 750-page Web Handling Handbook. While weight is common, there are many complications, a few of which are listed here. The first is that weight by itself contains no information about variability. For example, the weight can vary across the width of the machine, which is known as profile. We will discuss profile in more detail in Web20169b. A weight profile variation can in turn cause troubles with bagginess, winding, and many other quality concerns. While variation across the width is usually the largest as well as the largest area of concern, the web's weight can also vary down the length or with time. One issue with either variability is that you may need to increase the average weight to cover for the thinner spots, and that cuts into profit. Another major web handling concern is with resolution or goodness of the profile measurement. Not only with weighing of samples, but especially with scanners and especially with thin materials. It is not uncommon that the resolution of $1 million scanner is simply not good enough to see the variation that might cause problems at the winder, especially with thin materials. Furthermore, even if we do the usually far more precise weighing in the test lab, we introduce a new problem, and that is with the statistical validity of capturing roll averages from sampling at the top of a roll. The reason is, obviously, once you think about it for a moment, we may be sampling 1,000th of a square meter and trying to infer what a roll of 1,000 square meters might be. One way to double check our basis weight measurements is to weigh the finished shipping roll. However, we then introduce a new issue, and that is we need to have good roll length measurement, which is usually the case unless the rolls are very short or the web is stretchy. Roll length is also covered in an upcoming clip. I dutifully take the samples from the top of the roll, as I and dozens before me have done for decades. Who am I to question? Then I bring them into the test lab for die cutting and weighing. Who am I to question? Somebody probably knows where to find the written test procedures, so who am I to question them? The results are typed into a computer. Not sure if anybody looks at them, but I am just doing my job. Who am I to question? Well, it is time to stop doing what you've always done and answer just a few questions. How good are the instruments and procedures? Has someone done a round robin or a gauge R&R? Is the test predictive of product fitness or customer acceptance? Or are we just testing what is commonly tested? Are the rejection specifications too tight, causing unnecessary producer risk, or too loose, causing unnecessary consumer risk? If we test every roll and almost none is out of spec, is the rejection specification useful? This is an economic and statistical question that has an answer. Do your homework. Finally, is the half dozen samples you take from the top of the roll sufficient to make credible claims upon the roll itself? Here, Paul Frost can guide you. One of the best and simultaneously least known works on testing is the publication of Paul Frost, as listed here, that is from the Roysum Library Database Search Tool. Here you will find answers to whether your scanner is good enough and whether your test lab is good enough to make rejection or fitness claims. There are two starting points to learn more about material behavior in testing. The first is the must-have 750-page Web Handling Handbook. We have an entire chapter on material properties and many pages of test standards in Appendix T that would be useful for quality control, troubleshooting, and web handling work. The next is my award-winning and trademark Web 101 class that has been taken by 5,000 students just like you. Here we will learn which material properties are needed for web handling work and why they are predictive. Thank you so very much for joining me in this Material Matters series. Stay tuned for the next clip where we will talk about our most important property, thickness. If you have a topic you would like to hear about, let me know in the comments section below. If you found anything interesting or useful here, please like and share and subscribe. Also, please consider supporting the work of this channel using the Patreon link below. See you next time.